Hi, Anna here. Welcome to another video from Snob. AI is about to outgrow its original idea. Here's what comes next. For nearly 70 years, almost every artificial intelligence system has been built on the same underlying idea. That's not marketing language. That's not exaggeration. That's a historical reality. We've changed how big the models are. We've changed how fast they run. We've changed what they can produce, but we haven't changed the idea they're built on. And that single fact explains something that has quietly bothered researchers, engineers, and businesses for years. Despite all the progress, despite the headlines, despite AI being everywhere, today's systems still struggle with things humans do instinctively: reasoning, common sense, understanding why something happens, not just that it happens. This isn't because AI engineers aren't clever enough. It's because modern AI is standing on an idea that was never designed to do those things, and that idea is starting to show its age. In this video, we're going to explore where that idea came from, why scaling it has reached its limits, and what could finally replace it. Because the next real era of artificial intelligence won't begin with a bigger model. It will begin with a new foundation. First, the old idea beneath modern AI. To understand where AI is going, we need to slow down and look honestly at where it started. In the late 1950s, a psychologist and researcher named Frank Rosenblatt introduced something called the perceptron. At the time, it was revolutionary. The perceptron was inspired by biology, a simplified mathematical model of how neurons might work. Inputs go in, weights are applied, an output comes out. If the output is wrong, the weights are adjusted, that's it. And for its time, this was powerful. It gave researchers a way to build machines that could learn from data instead of following rigid rules. Over the decades, that single idea was extended, layered, and scaled. One perceptron became many. Many became layers. Layers became deep networks. Fast forward to today, and we have systems with billions of parameters. But here's the uncomfortable truth. Despite all that progress, modern AI hasn't replaced the perceptron. It has multiplied it. What we now call deep learning is an extremely sophisticated extension of a very old idea. And that matters. Because when you understand what the perceptron can and cannot do, many of AI's current limitations suddenly make sense. For a long time, scaling worked spectacularly well. More data, more compute, more parameters. Each jump produced impressive gains. Language models got more fluent, image models got more realistic, speech systems got more natural. This led to a powerful assumption that intelligence would eventually emerge if we scaled far enough, but something subtle has changed. The gains are no longer clean, the costs are exploding, and the failures are becoming harder to ignore. AI systems don't fail gracefully. They hallucinate, they overgeneralize, they sound confident while being wrong. This isn't a software bug. It's a structural consequence of what these systems are optimized to do. They don't understand meaning. They don't reason about causes. They predict patterns. Scaling makes pattern prediction better. It does not magically turn prediction into understanding, and that's the wall we're starting to hit. One reason this issue is hard to talk about is that AI looks intelligent. Language models, in particular, are persuasive. They speak fluently. They explain concepts. They answer questions. But fluency is not comprehension. A system can produce a convincing explanation without understanding a single thing it says. That's not a criticism, it's a description. These systems learn statistical regularities in language. They learn what words tend to follow other words. That's incredibly powerful. But it's also fundamentally different from reasoning. This is why AI can ace standardized tests, yet fail simple logic puzzles. Why it can summarize philosophy, but struggle with basic cause and effect reasoning, and why adding more data doesn't solve the problem. Because the problem isn't lack of information, it's lack of structure. So, What would a real AI breakthrough look like? Not a press release, not a benchmark win, not a bigger model. A genuine paradigm shift changes what the system is capable of in principle. To qualify as a foundational breakthrough, 3 things must happen. First, there must be architectural novelty, not rearranging existing components, introducing something genuinely new. Second, there must be a conceptual shift, a different understanding of how intelligence works. And third, the system must solve problems that were previously out of reach, not just perform better on familiar tasks. History gives us a useful comparison. Steam engines didn't evolve into internal combustion engines by getting bigger. They were replaced by a different idea. AI is approaching a similar moment. One of the strongest signals is dissatisfaction. Researchers are increasingly vocal about the limits of current approaches. Instead of asking, how can we scale this further? They're asking, what's missing? This has led to exploration of alternative architectures. Some focus on time, systems that evolve continuously rather than being trained once. Others emphasize memory, consistency, and long-term reasoning. Then there's the resurgence of hybrid systems. For decades, AI research split into 2 camps. Symbolic systems that reason logically, neural systems that learn statistically. Each had strengths. Each had fatal weaknesses. Hybrid approaches aim to combine both. Statistics for perception, symbols for reasoning. Not as a compromise, but as a necessity. Another quiet but critical shift is happening below the software layer. For most of AI's history, intelligence ran on hardware designed for general computation. Now that's changing. Neuromorphic chips, event-driven architectures, energy-efficient designs inspired by biology. This matters because intelligence is not just an algorithm. It's a physical process. Changing the substrate changes what's possible. Efficiency enables autonomy. Latency enables interaction. Architecture enables new behavior. This isn't flashy, but it's foundational. Perhaps the most important conceptual shift is causality. Today's AI is correlational. It learns what tends to happen. Humans reason causally. We understand why things happen and how to change outcomes. Causal AI aims to bridge that gap. A system that understands cause and effect can generalize beyond training data. Make reliable interventions. Explain its decisions. This alone could address many of today's reliability problems. Most AI systems today are passive. They learn from static data sets. But intelligence shaped through interaction is fundamentally different. This is where embodied AI comes in. Systems that learn by acting, not just observing, whether through robotics, simulations, or virtual environments. Interaction forces systems to deal with reality, noise, uncertainty, consequences. This kind of learning produces a different kind of intelligence. The final shift is from analysis to discovery. AI systems are beginning to propose hypotheses, design experiments, guide scientific exploration. This changes the role of AI entirely, not as a tool, but as a collaborator. This is early, but it's profound. All of this matters because the limits of current AI are no longer theoretical. Businesses see brittleness. Researchers see ceilings. Governments see unpredictability. The next era of AI won't just improve tools. It will change medicine, security, science, decision-making, and it has already begun. AI isn't just evolving, it's preparing to outgrow the idea it was built on. When that happens, the change will be deeper than any product launch, more disruptive than any model release, and more important than most people realize. The future of artificial intelligence won't arrive with an announcement. It will emerge quietly, through new foundations, new assumptions, and new ways of thinking about intelligence itself. And the people who understand that shift early won't just use AI better, they'll shape what comes next. Hit like and subscribe if you like this video, and I'll see you in the next one.